Hello everyone. Today we are going to discuss about delta modulation. So first before going to delta modulation, previously we were discuss about pulse code modulation. Where pulse code modulation implementation is good only, but the practical limitation is there where the circuit complexity is high. So that is the limitation for pulse code modulation. So in order to overcome that limitation of PCM, we are going for delta modulation. So what is the need for simplicity of implementation and circuitry? We are going for delta modulation, where the delta modulation satisfies these requirements by oversampling the message signal. But here one problem is there, the trade-off. So we have reduced system complexity, but with a trade-off of increased bandwidth. Here the transmission bandwidth is increased with a trade for reduced complexity. So delta modulation can be viewed as the dual of differential pulse code modulation. The exploitation of signal correlations. I mean, previously I said oversampling a baseband signal to increase the correlation between adjacent samples. So for implementing this quantization strategy. In another way, delta modulation is said to be 1-bit version of DPCM. The differential pulse code modulation 1-bit version is called delta modulation. Precisely like that. Here, from this waveform, we can explain easily about the delta modulation, where the sine waveform we can encode into a binary sequence. How we are going to encode this into a binary sequence? First, we need to understand this relation, where u of t is the staircase approximation what I am going to construct now, and x of t is the continuous waveform, continuous sinusoidal waveform what we have and what we need to convert or encode into a digital format, binary format. So first, x of t, we have to understand a relation where u of t is greater than x of t. When the staircase approximation value u of t is greater than the continuous signal value x of t, then the next step for u of t should be decremented. Next step should be decremented. If this relation is satisfied, if the u of t, staircase approximation of present instant, is less than the value of continuous time waveform, then it should be incremented. So likewise, we need to adjust these levels of u of t in such a way that we will convert this sinusoidal waveform into encoded binary waveform. So for example, let us take a pointer. See here, first let us say I am at this particular point, u of t. So now I will compare the value of x of t here with u of t. From the particular picture, I can come to know that x of t is high, x of t is more value greater than u of t value. So which relation satisfies this one? So, or else I will erase this one. We'll start newly. See here. Yes. If the u of t is greater than x of t, decrement. Say for example, the sinusoidal waveform is moving from here to here, like this it's moving. So now u of t is there at this level. So it is explicitly know that the sinusoidal waveform is getting decreased downwards. So now this instant I am having the value of u of t here. Next instant, this x of t is decreasing. So blindly we can say that u of t is greater than x of t. So the first relation, u of t is greater than x of t. X of t keep on decreasing. So if we at any time instant at particular period, if we see x of t is small value, that means u of t is greater than x of t. So we should decrement this step size. So I have decreased the u of t by one step. Now at this particular point, we need to recheck the condition, u of t with x of t. So now it is decreasing. Still here it is decreasing. So u of t is greater than x of t. So again the first condition satisfies. So that's why it will decrement again one step, decrement. So here up to here it will come. So now I will take a new color of pointer. So I will take this color. Now here at this present time I am here. So here I am here. So at this time we will check for the recheck for the condition. U of t value is less than x of t. So here this at this particular point sine waveform is keep on increasing. It is used to increasing. So that's why the second condition will get satisfied. U of t is less than x of t. At this particular time u of t's value is less, x of t value is high. So the second condition satisfies. So u of t staircase approximation should be incremented by one step. So here where I highlighted with green is incremented with one step here. Okay, so here up to here where I have marked here up to here it will incremented. Then again here at this point it will recheck for the condition. I will take with a red. So here from here it will check this u of t condition. Here u of t is greater than x of t is this particular instant. So it will decrement. U of t is greater than x of t. So one step it is decremented. So likewise it's keep on checking this condition over each time interval. Say here we have a marked time interval ts. So this is one time interval ts. For every time interval ts it will happen either incremented or decremented by a size called delta. Here the step size is delta. So if the step delta is equal to 1 bit, that is called 1 bit quantizer if delta equal to 1. So with this sinusoidal waveform, continuous waveform x of t, the staircase approximation will be constructed. How we will encode this one into binary? So each time decremented you mark it as 0. Each time decremented you mark it as 0. Each time when incremented you put as 1. Increment 1. Here decremented 0. Again keeps on incrementing 1, 1, here 1, here 1, here 1, here 1. Decremented means 0. Here 0. Again here incremented 1. Here decremented 0. So continuous zeros here. So in such a way that a continuous time waveform is converted into a encoded binary format using digital modulation. So here one more factor we need to define is step size. What is the step size? Step size, the indicator, the notation is a delta symbol. This is the delta symbol is the notation for step size. So here in previous example either incremented by plus delta. So this is a step size delta. So for incremental it is plus delta, for decrement it is minus delta, where we have shown here. So plus delta means it will increment like this, minus delta means it will decrement here. So if delta value equal to 1, that is called 1 bit quantizer. Thank you.